You don't start a machine like this casually, you prepare for it, because what's about to happen isn't just ignition, it's an event that begins deep inside the metal. There's a moment, right before the button is pressed, where everything is still, and you know the silence is about to be broken by something engineered to dominate it. Then it fires. Not with chaos, but with intent. A sharp, controlled ignition, followed by a low, dense idle that feels like pressure building under the surface rather than noise trying to escape. This is where the story really begins. Because whatever powers a so-called R36 GT-R at this level, especially one pushing into 4-digit horsepower territory, cannot be ordinary. Can't just be an evolution. It has to be a complete rethinking of what a performance engine is supposed to do, and how it survives doing it repeatedly. Now, before we talk about power, before we talk about numbers, we need to understand what kind of architecture could even support something like this. Because at this level, power is not the challenge. Control is. It is. Durability is. And most importantly, consistency. You're likely looking at a highly reinforced, compact block, possibly derived from the legendary VR architecture, but strengthened far beyond anything seen before. Closed deck construction, to handle extreme cylinder pressures. Thicker cylinder walls, to resist deformation under boost. And internal components, forged, balanced, and engineered for repeated high-load cycles. Because when you're dealing with power levels that climb past 1,000 horsepower, the engine doesn't just experience stress, it lives in it. Inside, the crankshaft isn't just forged, it's precision balanced to eliminate vibration at high RPM under boost. The connecting rods, likely high-strength forged alloys, designed to handle both compression and tensile forces as boost pushes combustion beyond typical limits. And the pistons, coated, cooled, and shaped to manage heat, because heat is the enemy now. Not power. Heat. And that brings us to airflow. Because no engine reaches this level of output without moving massive amounts of air, efficiently, and consistently. Twin turbochargers, almost certainly. But not just for peak power. For control. Modern turbo systems at this level are about response just as much as output. Variable geometry, electronic wastegate control, optimized turbine housing design. Everything working together to eliminate lag. So when you press the throttle, even slightly, the engine doesn't wait. It responds. And that response is what separates a powerful engine from a usable one. Now imagine this in the city. You're not racing. You're just moving through traffic. Light throttle. Low RPM. And the engine feels calm. Not weak, not restrained, just controlled. Because modern tuning allows engines like this to behave almost like something far smaller when you're not demanding everything. You press the throttle just a little deeper. And you feel it. Boost begins to build, not aggressively, but progressively. Torque rises smoothly, filling the gap between idle and acceleration with something that feels effortless. This is where tuning becomes everything. Because delivering 1,000 plus horsepower all at once would make the car nearly unusable in normal conditions. So instead, the ECU meters it. Carefully. Precisely. Fuel delivery, ignition timing, boost pressure. All adjusted in real time. And what you get is control. Now step out of the city. Open road ahead. You press the throttle with intent. Not full, just enough. The engine drops into its power band, the turbos fully spooling, and suddenly the character changes. Acceleration doesn't spike. It builds, then builds harder, and then it holds. From mid-range into higher RPM, the pull becomes continuous, relentless, almost electric in its delivery, but with a mechanical depth underneath. You hear the turbos, faintly at first, then clearer. You feel the engine, not vibrating wildly, but loading up, pushing forward with controlled force. This is where the 50 to 90 miles per hour pull becomes something else entirely. Because this is not about launch anymore. This is about sustained power. And at this level, sustained power is where engineering either holds or fails. Here it holds. The boost stays consistent. The engine breathes efficiently. And there's no drop-off. Just a continuous wave of acceleration that doesn't feel like it's running out of anything. Now let's talk about the launch. Because 0 to 60 in a car like this is not just about power. It's about traction. It's about drivetrain control. It's about how the engine delivers torque at the exact moment grip is at its limit. You bring the car to a stop. Engage launch control. And the engine changes its behavior completely. RPM stabilizes. Boost preloads. Everything is primed. You release. And instead of chaos, you get precision. All-wheel drive systems, working with the engine, distributing torque exactly where it's needed. No excessive wheel spin. No wasted energy. Just forward motion. Violent, but controlled. And that's the difference. Because many cars can make power. Very few can use all of it. Now compare this to something like a Porsche 911 Turbo S. That car delivers power with surgical precision, incredibly refined, almost clinical. But here, there's more aggression. More raw mechanical presence. Or take something like the Chevrolet Corvette Z06. Naturally aspirated, high revving, emotional. But it doesn't have this kind of torque wave. It doesn't have boost building behind the scenes, ready to surge forward. And then there's something like the BMW M5 Competition. Twin-turbo V8, all-wheel drive, incredibly fast. But heavier, more insulated. This feels more direct, more focused, more like everything is happening closer to you. Now back to the engine. Because sustaining this level of performance means dealing with heat constantly. Multiple cooling systems are almost guaranteed. Primary radiator, upgraded. Oil coolers, likely multiple. Intercooling systems, possibly air-to-water for faster thermal management. Because when intake temperatures rise, power drops, and risk increases. So the system works continuously, pulling heat away, maintaining stability. Now let's talk about repeated pulls.